Hi, welcome to session 7. In this revision session I'm going to be looking at clouds. So what is a cloud? Clouds are basically visible moisture in the atmosphere. All air contains some moisture in the form of water vapour, which is an invisible gas. It's actually an invisible gas which is only about 2/3 the density of nitrogen, the main gas in the atmosphere. So it's quite a light gas, surprisingly. If you cool any parcel of air, it eventually reaches a point where it can no longer hold the moisture as water vapour, as a gas, and it condenses out into visible droplets. And that's what we see as cloud. Usually they're water droplets. If it's high enough, they'll condense out and then immediately freeze into ice crystals. So that's what a cloud is. It's just basically a visible manifestation, if you like, of the water content of the air. So we're going to look at how clouds are categorized and what they tell us. So basic cloud types then are cirrus. Cirrus is high ice cloud. So this is really high up, doesn't matter how high. And it's very wispy, has a characteristic look. They tend to be, mare's tails is the common descriptor of it, just wispy clouds which are obviously translucent. You can see blue through them. So that's cirrus. Stratus is layer cloud, and that is anything that's arranged in a flat, sort of continuous bit of overcast, as it were. So we get different kinds of stratus cloud. And because it's layer, not only is it different levels, you get different kind of clouds. Sometimes it's bumpy layer, sometimes it's flat layers, what have you. But anything that's a stratus, stratiform is a stratus cloud. And then cumulus, which is convection or heaped up cloud. Cumulus is caused by warm air, convection obviously. So you get a big parcel of warm air, a few tons of warm air going up, and it reaches dew point where it turns into a cloud. Because it's moving fairly quickly, it just carries on for a while. So you get this heaped up sort of shape showing as the air mass is decelerating. Okay, so those are the basic types of cloud, those three types. And then there's prefixes that we add to them. Fracta means broken. So in other words, if you have a fracta stratus, it means it's cracked up into little pieces. Fracta is obviously the same root as fracture, same as breaking your arm. And the other one is nimbo, which means rain bearing. So a nimbostratus is a cloud that's, a layer of cloud which is raining. Okay, and then we have categories depending on where they are in the sky. So cirro, slightly different word to cirrus, or the same sort of area. And these clouds that are above 18,000 feet. Alto are clouds, mid-level clouds, so they're above 8,000 feet but below 18,000 feet. And if they're low clouds below 8,000 feet, there's no prefix to them. Or there are sometimes prefixes, but not to do with altitude. So here's an example. Here's cirro-cumulus. So we already figured out from this. Cirro means above 18,000 feet. Cumulus means a heaped cloud. So it's not a very common cloud, but little heaped clouds there at high level. Alto-cumulus, a lot more common. So mid-level cloud, but again, heaped cloud, heaped in nature. Stratocumulus. Right, this is a mixture of two different types. So this is a layer of heaped cloud. You see how the names are generated there. It's fairly straightforward. Nimbostratus, already mentioned this one. So this is a layer of rain-bearing cloud. Orographic, right, that's a new one. I haven't mentioned orographic cloud. So orographic cloud is essentially, cloud is formed, as mentioned, is when the air mass is cooled. So there's different ways of cooling an air mass. If it's a cumulus cloud, it's, operates by convection, but that's not the only way. Sometimes an air mass is moved upwards, usually by a front or something like that, but sometimes by a hill. So in this case, orographic cloud is a hill. This is a coastal site, but it can happen on other sites as well, where an air mass hits a physical piece of terrain, is pushed up and up until it reaches dew point. And so the cloud forms on the hill. So hill fog, if you like. Orographic cloud. Very interesting to pilots in particular, because we fly on windward slopes. If we're flying on a mountain somewhere, we often get orographic cloud in the morning. If you're flying on a coastal site, it's quite common to have clear air, and especially as the sun goes down later on in the day or in the autumn, where the temperature drops slightly, the dew point temperature, which was high up above the hill, actually comes down and down until it reaches where the air is coming up over the hill, and the cloud can then just form very quickly. I've had a situation where I'm flying along in clear air, turn around and flew back. By the time I got back to my takeoff area, it was completely wreathed in cloud, orographic cloud, so it can happen very quickly. So it's important to know about as pilots, because if you're up there and cloud starts to form on the top of the hill, you need to land pretty quickly if you're going to land on the top when you can still see where you're going. But you usually have an escape, and you fly out away from the hill, you'll get out of where out of ridge lift means out of the cloud as well. So you have to end up landing down at the bottom. So that's orographic cloud. Mist and fog, just another kind of fog really, but the other way of an air mass being cooled is if it's lying on a cold surface. So in this case, this is radiant fog here, and there's a couple of different sorts. Radiant fog is where an air mass, often overnight, is lying on a surface which cools down a lot, radiates heat, and it reaches the dew point. It's an almost daily occurrence, so you get dew on the grass. But if the temperature profile is correct, you not only get dew, you actually get mist forming on the ground. Can be very patchy because it all depends on the underlying temperature. So you've probably all seen patches of low-lying mist on a particularly cold or wet bit of ground, or just over a river or something like that. So that's mist and fog. The difference between mist and fog is just that fog is a denser form of mist, but it's all the same thing. I mentioned radiation fog there, or radiation mist, and that's what you can see in this picture. There's another variation as well on that. You can have advection fog, and that's usually where fog is caused very often over the sea for the same reason, but then the wind blows it onshore. So you actually, and it persists for a little while, so you actually get incoming fog. And that's actually quite common around the coasts in the UK. So that's advection fog. Right, some variations now. Cumulus congestus, yet another, well, it's not a prefix, whatever it is. Congestus is just a way of describing the fact that this cloud is very built up. So this is a large cloud. If you see on this picture here, you can see it's beginning to smooth over the tops there, because the top of this cloud is thousands of feet high and it's up into the high level winds there. So it's well on its way to becoming a storm cloud. So what's this telling us? This is telling us that there's massive, imagine the air that's having to go up to form that cloud. There is a lot of vertical development there, and therefore we are going to expect very strong lift underneath that, to the point where it's probably going to be hazardous for flying. And talking about hazardous clouds, this is the daddy of them, the Cumulus-nimbus cloud, or Cumulo-nimbus cloud, or CB, they're referred to on weather charts and for short. Literally, Cumulo-nimbus means a rain-bearing cumulus cloud, and that's what it is. But the term means, generally taken to mean storm clouds, so those with massive vertical development. When a cloud builds fast enough, it actually gets up, and there is a lapse rate, that is, the temperature drops as you go higher, and it starts to accelerate and go huge heights. When it starts to get up sort of 15,000–20,000 feet, it gets up into the high level winds, and the top often blows over, so you get this kind of anvil shape on the top. If a cloud is that big, it starts to generate its own weather, so you actually get very strong lift underneath it. You get downdrafts as well, microbursts as they're called, and you get severe turbulence. Because it's so big, you get a gust front out ahead of it as well. So just time for a little story here. A hang glider pilot of my acquaintance was flying in the Yorkshire Dales, and he could see a cumulo-nimbus cloud coming. You could see it was a big towering storm cloud, but it was still kind of, a mile or more away. So his car was at the bottom. He wanted to fly down and land. It wasn't a particularly big hill. So he grabbed all his gear, stuffed it in his harness, took off and headed off on his hang glider towards the bottom landing field. Well, a hang glider will fly at kind of 50 miles an hour full bore, but he never made it. Even though the cloud appeared to be quite a long way away, he just got sucked up into it. Got hailed on, could see lightning, what have you, got soaking wet, freezing cold, and he actually got spat out several miles away. He said when he landed, he was holding on to the ground. Okay, so gives you an idea. Cumulus, not a very good idea for pilots for that reason. So violent updrafts, we mentioned hail, soft and hard hail, sub-zero temperatures. Obviously hailstones are developed from water droplets bouncing up and down inside the thermal cloud, and basically bad news, possible lightning. Some of you may know the story in Australia. A few years ago there was a major paragliding competition, the practice day. A lot of pilots were flying and they flew, and there were a couple of thunder cells. Some of the pilots sort of shot through the gap between them and some others followed them, and the cells actually coalesced and they got caught. So several pilots got sucked up. One of them, Eva, got to 36,500 feet, I think. So human hailstone, which he was really, really lucky to survive. Lost consciousness and frostbite and all that kind of thing. One of the other pilots, sorry, I don't know his name, one of the Chinese pilots was actually struck by lightning and killed. So cumulus clouds, if you weren't frightened of them before, I hope you are now. Stay away. So tips for flying near cloud base. If you're up there and you worked your thermal and you're up near base, it's quite hard to see directly above you. You can see other clouds around you. So if you look out, you can see what they're doing. If they're all towering, chances yours is a towering cloud as well. So you get out, get near the edge. What you can do is you can see the colour of your cloud, and the darker it is, the more vertical development, because that means the less light is shining through. It varies a bit because it depends on the angle of the sun and the time of day. But a dark bottom cloud means that it's got a lot of visible water droplets in it, and therefore it's going to be pretty high, and therefore it's likely to be very powerful lift underneath it. So it's looking kind of dark, start edging out towards the edge or get out of there. When you get towards cloud base, get to the edge of a cloud. If it's a huge cloud, you don't want to be stuck in the middle. You don't want to get sucked into cloud and not be able to see where you're going. It's a horribly disorientating thing. I've been in cloud on both a hang glider and a paraglider, you know, although the paraglider you've got this pendular stability here underneath it, with the hang glider I found myself banked up when I came out of it and I thought I was flying level. It's amazing how disorientating it is. So get yourself over near the edge of the cloud so you've got an escape route. When you're actually at cloud base, you go up and it's a nice sunny day and there's a puffy cloud above you. You get to cloud base, suddenly everything goes grey and horrible. Partly because you're close to the cloud, but also because of your parallax view. You can't see the sunny patch, or you can see all the clouds everywhere, so it looks like the sky is full of cloud. It's often an illusion, but if you look down, you can see sunny patches on the ground. That's how you can judge the density of the cumulus clouds. So you can use the spacing of the cloud shadows to sort of work out how far it is to the next cloud and whether there are still some sunny patches. Obviously, if a lot of the ground is in shadow, that does actually reduce the chances of further thermal. So you want to stay somewhere with a mixture of shadow and sun. If you're comfortable, if you're up there and you're doing all right and you're in control, stay with your cloud. What actually happens is, as we saw in the diagram earlier, the thermal lift goes up and then cooler air sinks to fill the space around. So if you've got strong lift, you're going to have quite a lot of sinking air just around it. So if you leave your thermal, the first thing you're going to do, the first 100 meters or so, is you're going to sink quite heavily. And it may be fairly turbulent where the air is traveling in different directions, sort of shearing. So quite a good idea is to stay with your cloud if you're comfortable as you go along until the lift deteriorates to sort of zero or very light. At that point, not only have you probably drifted quite a few kilometers, which presumably is what you're trying to do, is cover a bit of ground, but also the sink will have deteriorated as well. So if you leave in a zero, you probably have a fairly easy glide, and then you can pick out the next developing cloud or ground feature that might generate a thermal to go and hang around over. So don't rush. A lot of pilots, first time they get big thermals, they get up to cloud, go hurtling off straight away and suffer the consequences. If you suspect that it's overdeveloping, so you can see rain on other clouds, or yours is very dark, or the lift is very powerful, just land. As mentioned, it's just not worth the risk. So some other clouds. This one here is a lenticular cloud, and I think I can play this as a video, if you just give me a moment. Okay, so you can see the lenticular cloud. The interesting thing about this is it's pretty windy, but the actual clouds are not moving. So that's unusual. This one's taken sort of at dusk. So what's going on there? Well, lenticulars are caused by wave. So this is an illustration of wave. An air mass does ripple, a bit like waves on the ocean, but more so. If it gets forced up over a line of hills and then sinks down again, it still has a bit of energy, so it tends to bounce a little bit. Now usually, like ripples, they sort of just get ironed out as you go downwind. But if there's another hill with another injection of venturi, which gives it a bit more speed, just at the point where that bouncing air is going up again, it can massively increase the vertical thing. And if you have several hills, you can end up with huge waves that go up to thousands and thousands of feet. That's the classic example of how wave happens, and that's definitely the case, but it's not the only way. I've actually flown on the west coast of Scotland, where the next bit of land upwind is probably America, but nevertheless we were flying in wave lift and got little lenticulars forming. So the air just can bounce on its own, really. It might have been caused by a frontal system or something like that, I don't know, but you do actually find wave more frequently than people sometimes think, particularly in the upland areas of the UK. Right, it's worth knowing about wave because it has quite an interesting effect on our flying. So the first thing is the lenticular clouds mark it, and as shown there in the little video clip, they stay still. And the reason is that the air is pouring upwards, reaching the dew point, forming a cloud, and then pouring back downwards on the other side, and then evaporating again, if you like. So the cloud actually remains still, even though it might be quite windy. So one of the classic signs of wave. You can see from this diagram that the air is bouncing up, and it goes up thousands of feet. You can be on the ground and you can be experiencing sort of what's really a 10,000 foot wind. So it can feel really windy. And then a little while later, a little bit further along, hardly any wind. So that again is a classic sign of wave. If the wave is in phase, as we call it, in other words, you're on a hill and you've had a bounce in front of you and the bouncing air is hitting your bit of ridge lift, then it's brilliant. You can take off, lock into the wave, start flying up. The highest flight I ever had in the UK was in the Yorkshire Dales, and we were at something like over 9,000 feet. You can see both coasts, which is strange. But I wasn't too worried about it because I was too busy being freezing cold, so I had hands in my armpits. But wave, it can be very smooth and easy lift. So it's like giant, super smooth ridge lift, which is great. But it's not always like that. Sometimes you can get out of phase wave, and that is where the air is pouring down at your hill or at your takeoff point. So it feels quite windy, it feels like there should be plenty of ridge lift, but actually there's hardly any lift. So you have all the disadvantages, really. So it can work for you, it can work with you. Waves often move as well, so you might have a half hour when it's okay, and then a half hour where the wind drops off or becomes much too strong, and then so on. So if you know a local site and you need local advice for this, they often have their own characteristics of how they behave in wave and when it is suitable to fly there and when it isn't. Can be quite dangerous. When the wind is strong in particular, and in wave, occasionally the waves, just like a wave in the sea, can actually break and you can get quite nasty turbulence. Another story, I used to work once upon a time for a hang gliding manufacturer, and a guy turned up once with his broken hang glider in the back of his van as opposed to on the roof, which is never a good sign. And he'd flown a well-known wave site in the Peak District, Bradwell Edge in fact. He'd got there to take off and there's almost no wind. It was very light winds, but he could see a sailplane above him hovering, pointing into wind, stationary, I don't know how high, a couple of thousand feet, let's say. So he took off, which I wouldn't have done, I'm forced to say, took off, contacted wave, went up, started flying out, and he actually got, the nose started to drop his guy and he went right down and got turned completely upside down and fell into the sail of his hang glider through his emergency parachute and ended up in a heap on the ground. So very strong winds, wave can be quite a severe hazard. Not usually a problem to paraglider pilots because we just don't fly in winds that strong, but certainly it's possible to access with a hang glider, and it could be the case with a paraglider. So wave, treat it with great respect. Okay. So here's a few keys as to whether there's wave around. If you get there and the wind is not what you're thinking, just so I think, then that's a thing. If it's been windy for a few days, that is how wave builds up. It sometimes takes some time to build up. So it's calm yesterday, it's unlikely to be wavy today. And as we mentioned, the clouds tend to be stationary. Lenticular clouds are a common indicator of wave, but there can be wave without lenticulars, worth mentioning. And they're the one, yeah, I've just mentioned there. On your way to the site, if you think, oh, it's windy, oh, it's not that windy, oh, it's windy, and then you get there, that's a classic sign of wave. Okay, so that's a basic introduction to some little bits of cloud lore, if you like, that you might find useful. So help you identify what the clouds are and some of the hazards that are associated with them. I hope that's helpful.